think it is pretty neat or cool or awesome, showing my age, that the MEADOWS family is still manufacturing the asphalt expansion joint, and it's one of a very good seller for us. So from one location and manufacturing one product, now the MEADOWS family has 11 locations in the United States and 2 in Canada. In Sherwood Park, it's a brand new plant. It's absolutely beautiful. I have not seen it because of COVID, but I've seen pictures. And our head office for Canada is in Milton, Ontario. And the head office for the United States is in Hampshire, Illinois, which is very close to Chicago. So like I was saying, from one product, now the MEADOWS family is manufacturing over 360 lines, not products, lines. So some of the MEADOWS family of products would be the expansion joint materials. And like I was saying before, the first one was the asphalt expansion joint. And if you actually see the asphalt expansion joint or the fiber expansion joint, it's very rigid. And it is for straight expansion joints. Typically, like if you look down at a sidewalk, that's a nice straight expansion joint. So it's perfect for rigid materials. The MEADOWS family had to extend this line because now we have curvatures to some expansion joints, or you have a column. So you have expansion joint around the column and you cannot have a rigid material. So now they manufacture very, very pliable expansion joint materials called Decofoam and Ceramar that are very pliable, very light, easy to cut on site and for curvature applications. They have a whole line of concrete restoration products. And to me, this is very important as I will be talking about effective waterproofing today. So as we all know here, when they pull the form on a traditional waterproofing application, they can't just start waterproofing right away. There's probably bug holes, honeycombing, voids that need to be patched prior to waterproofing. So we have a whole line of structural and surface repair mortars for horizontal, vertical, and overhead. They have really extended the construction liquid line. We now can offer 100% silanes for slab-on-grade parking garages. We have silane siloxanes, curing compounds, curing and sealing. So please get in touch with your local rep to talk about penetrating sealers versus film forming, as we do carry all of them, and depending on your application, depends on what you need. Then we have joint sealants. We manufacture hot and cold applied that should go onto expansion joint materials. A whole line of decorative concrete. So basically we can make your beautiful decorative concrete pop, shine, really accentuate the beautiful colors. The building envelope today, I will be talking about waterproofing and vaporproofing of the underslab, as well as positive side waterproofing and negative side waterproofing. We have a whole line of above grade vapor barriers and vapor permeable barriers, but that's a whole nother presentation. The MEADOWS family also has the Blue Ridge fiber board, and they manufacture the soundproofing and insulation board. So this presentation is an AIA presentation, and all registered architects are able to collect a learning point or self-directed point. So effective waterproofing. So my objectives today are to discuss the mechanics of the moisture movement and the resulting, oh sorry, my camera's in, resulting issues within our structures. Explain some of the issues relating to concrete deterioration as a result of water penetrating into our structures. Differentiate between damp proofing, waterproofing, and vapor proofing. And to me, this is very, very important. A lot of times, damp proofing compared versus waterproofing is very, very misunderstood. Sometimes it's not spec'd correctly, or the contractor misunderstands, and there's a big difference between these two types of materials. Differentiate between positive side and negative side waterproofing. Again, very important. There's a lot of products that can be placed on the positive side of a wall, but cannot be placed on the negative side. And we'll be going over the products and the applications. And then identify the various types of below-grade waterproofing systems to control this moisture movement. So there's many ways moisture moves around us, and it's very important to understand some of the ways moisture moves. So one of the ways is the hydrologic cycle. And basically, this is the water cycle, also known as the hydrological cycle. And this describes the continuous movement of water on, above, and below the surface of the earth. So basically, if you have sun beating down on a large bed of water and the water evaporates up into the sky, the water changes to vapor. Vapor forms clouds. The clouds build until they no longer can hold, and they release in the form of precipitation. And it can be rain, snow, ice, drizzle, you name it. And why the cycle is very important to understand or just acknowledge that it exists is that we are now building our structures within this cycle, within this constant water cycle, so that we need to address this cycle to stop the moisture and the water from coming into our structures. Another way that moisture moves is through gravity. So what we know is Earth's gravity pulls precipitation down from clouds and pulls water downhill. Gravitational water is excess water. Basically, gravitational water will cause increased groundwater levels and surface runoffs. So again, very important to understand or acknowledge. Then we have the capillary. So when I think of the capillary action is when I think of a sponge. So if you have a sponge and it's drawing water towards your structure. So if you have fine granular soils around your structure, they work as a sponge. So they actually draw water towards your structure. And there's been studies that actually the draw is from very, very far areas that are drawing toward the structure. So that's why a lot of times you hear capillary break, and capillary breaks are very, very important because they are large granular materials that will be around, especially on your underslab, and they basically stop the rise of water against gravity into your structure. So capillary breaks are very important. Then we have diffusion through a material. And this all has to do with temperature and relative humidity, and also the season where you live. Texas compared to Toronto, very different. Also summer and winter. So which way is the vapor traveling through your structure? Air transport, we have a lot of moisture latent air transporting or blowing towards our structure. Does this need to be addressed? I think so. Another thing is dew point. So dew point is the temperature. The air must be cool to get 100% relative humidity. Interesting point is that the dew point temperature is never greater than the air temperature. So how does moisture enter the structure? So one way definitely is liquid water. So when we talk about liquid water, we definitely talk about the water table. So do you have a high water table, a lot of height, weight, and density of water pushing up against your structure, trying to, well, not trying to get in, but trying to find a weak spot to infiltrate into your structure? Or do you have a low water table around your structure? So the lower the water table, the lower the pressure of hydrostatic pressure against your structure. Or if you're in another situation, your water table might be below your slab on grade. So again, very important to know where your water table is around your structure. Geotechnical report is very important. Then we look at site drainage. It used to be much easier to talk about, but now if you talk to any manufacturer rep, if you have a traditional wall concrete wall. Then you place, pull the forms, let it cure depending on the manufacturer's product. Then you place a waterproofing membrane on there. Then you place a drainage plane. So what that does is that when the hydrostatic pressure hits the drainage plane allows the water to drain down the wall to the weeping tiles or some sort of pumping system that pump the water away from the structure. Sometimes this is not possible, as if you live in an urban area like Toronto, Los Angeles, anyways, a city, an urban area. You could even actually be different regions around the world. Depending on where you are, there's two ways that the city will let you deal with your water. One could be bathtubing. And what bathtubing is when you see those big holes, and basically they have a soil retention system as wood lagging, caisson walls, shotcrete holding the earth out of the hole. And then we waterproof onto the soil retention system, and then they pour the foundation wall. And what bathtubing does is that with bathtubing, there's no weepers or a way of pumping the water away from your structure. You are relying on the membrane that is placed under slab and on the walls from stopping the water from entering into your structure. The second way that some cities will let you deal with water is actually have the waterproofing on the positive side, have the drainage plane, hydrostatic pressure comes, drips down, it flows down to the bottom of your wall. You probably have interior weepers if this is in an urban area. The interior weepers are hooked up to a piping system, and the water is directed to a large holding tank. And in this large holding tank within your structure, a lot of times they will ask you to clean the water prior to introducing it into the city water. This is because we have so many structures now in urban environments, that the owner is responsible for cleaning its water prior to introducing it to city water, because our wastewater treatment plants and water treatment plants are just overflowing, and they basically need help. Another way liquid water can basically enter into our structure is looking at sprinkler systems. You have these beautiful structures and beautiful landscaping around these beautiful structures. This landscaping requires water. So we introduce sprinkler systems. So it doesn't matter what way you are trying to basically stop the water from coming into your structure, you definitely have to take into account that you're adding more water around your structure with sprinkler systems. So whatever system you're using, make sure that it can accommodate the extra water that you're introducing to stop it from coming in. Cracks. We all know that concrete cracks, and the older the concrete is, more cracks will develop. We definitely do not want a crack basically joining together at hydrostatic pressure and water finding that crack, able to flow right into our structure. Cracks need to be addressed. A lot of times, if it's possible, even before we start to waterproof, we should be addressing the cracks, meaning doubling up on them, or whatever the manufacturer's way of addressing cracks prior to putting a full sheet over that foundation wall. Improper waterproofing details. I'm a huge fan on properly training the waterproofers on how to install as per manufacturer's recommendations. Have the manufacturer rep come on site to make sure it's being installed as per manufacturer's recommendations, the proper detailing. Have a third-party consultant come on site, and also more eyes on the work, the better. The GC should be aware of the system and so forth. So more eyes on the work, the better, and more success will happen. So hydrostatic pressure, I already talked about this, but I love this illustration down here on the right. It's basically showing height, weight, and density. The more that you have, the stronger the pressure. The lower of height, weight, and density of water, the pressure is not so hard. Capillary. Again, I love this illustration. This illustration is showing when you have a small diameter, you have greater rise against gravity. When you have a larger diameter, to say aggregate, then you have a lower amount of rise of water against gravity. Another way that moisture enters our structure is water vapor. And what we know or understand about vapor is that it naturally will go from a pressure, if there's a high vapor pressure, it naturally will travel or push itself to an area of low vapor pressure. So in our soils, we know that the temperature is 13 degrees Celsius or 55 degrees Fahrenheit with a 100% relative humidity. So from those numbers, they calculate the vapor pressure in our soils to be about 0.214. So it's quite high. It's a very high vapor pressure naturally in our soils. And in our structures, typically the temperature, we keep it at about 70 degrees Celsius or 20 degrees, shame on me, I'm Canadian, 20 degrees Celsius or 72 degrees Fahrenheit, and the relative humidity is 30%. So from those numbers, they calculate the vapor pressure to be about 2.104. So basically lower. So now we have a natural vapor drive from the soils. And what we know about concrete, it's not a good vapor barrier. It's permeable and porous and lets the vapor through and into our structure. So it's going from an area of high to low naturally. So again, depending on the application, depending on the flooring that you're putting on a slab on grade, you know, if this is a condo that has a parking garage underground, do you need a vapor barrier? Do you need to address this vapor? Probably not. But there's many situations or applications that, in our opinion, the vapor needs to be addressed to stop from coming in, or not stop, but basically a barrier to stop the vapor from coming into our structures. Vapor diffusion, I already talked about this. Basically, it's all about relative humidity and temperature on which way the vapor would travel depending on the season. So, description of concrete. So what is concrete? So basically, before we even talk about waterproofing, we need to understand what concrete is. And as far back as the records tell us, the Babylonians actually started using a concrete type building material to build their structures. But back then it was more of a clay material, and then more than a concrete type of material. Then in the mid 1700s, John Smeaton actually invented the concrete that we use to this day. I mean, it's a little bit more complex now, but he mixed cement with a small or large aggregate and water, and that he invented concrete. Like I was saying, the concrete that we use right in these days is definitely a little bit more complex. We have the plasticizers, we have admixtures and so forth. So even with our more complex mixtures, of course, there is advantages and disadvantages to concrete. And some of the advantages is relatively low cost. It does have sometimes, depending on the pour, a high compression strength, and it does have ease of fabrication. Disadvantages, of course, can have low tensile strength, and in some instances, it can have long-term durability issues. So, chemistry of concrete. So hydration. Concrete hardens by a process called hydration, and that is cement and water form a paste that coats the aggregate. And during this reaction, there is a number of compounds formed, and they are calcium silicate hydrate, calcium hydrate, calcium aluminate hydrate, and calcium fraurate. The calcium silicate hydrate is the most important of these, as it contributes to setting, hardening, strength development, and volume stability. The CH contributes by providing an alkaline environment, which is beneficial to the reinforcing steel, well, reducing the potential for corrosion in your reinforcing steel. Then we have the water to cement ratio, and this determines the concrete strength. Water also affects the workability and consistency of the concrete mix. So there is, of course, limitations to concrete. Although very durable, concrete naturally deteriorates from natural weathering. And what we mean by that is that the temperature, again, is this concrete poured in Texas, or is it poured in Toronto, Canada? Temperature has a great effect on concrete. Or aggressive chemicals. Have we not treated or not protected the concrete from the aggressive chemicals that we knew, or maybe we didn't know, was going to basically affect the concrete? Was the right mix used for the particular application, and were the right materials specified for that to protect the concrete in that particular application as well? So even good concrete, it can be described as permeable and porous. And what we mean by that is the definition of permeability is a measure of the ease with which fluids will flow through a material. That's a lot of F's. And a good example would be age of the concrete. So the older the concrete is, the more permeable it is, because you have a crack, and the older it is, then you have another crack. Those two cracks join together, and now we've made it easy for the water to flow through into our structure. Porosity. The definition of porosity is the ratio of the volume of openings to the total volume of material. And what that basically means, it all has to do with the water to cement ratio. So the greater the water to cement ratio, the greater the porosity. This also goes back to vapor barriers and water vapor. So the greater the porosity, a lot of times it is felt that and if you use a vapor barrier under your slab on grade, when you have a water to cement ratio, greater porosity, you can have slab curling. And when we are addressing this type of question, it all has to do with the water to cement ratio. So a lot of times, if you are specifying a vapor barrier retarder underneath your slab to prevent that vapor from coming into your structure, because you have a certain flooring, epoxy, polyurethane that is not permeable, basically the vapor will get stuck underneath, and you possibly could have a floor failure. You need to talk to your structural engineers. They have to look at the water to cement ratio and either lower the water in the water to cement ratio, or basically eliminate it and replace it with plasticizers. So you still have the flowability and workability of the concrete pour and lower the chance or potential of slab curling. So moisture control is essential for the function of a building, also the health and safety of the occupants within this structure. And also when you look at the heating costs and the HVAC costs, moisture control is very important to lower these costs, and also to protect the building from damages. So essential elements that affect moisture protection or the membrane is that you want a continuous uniform membrane or coverage Doesn't matter if it's a traditional waterproofing or blindside waterproofing. Continuous and uniform is very important. I was just on a site and they had glued the insulation already on a portion of the foundation wall, and they wanted to basically bring the waterproofing up to the insulation, and they thought that was fine and just terminate it around the insulation. And of course I said, no, you have to pull off the insulation and make the waterproofing membrane continuous, and then put the insulation back, and then put your protection board or drainage plane, and it will be successful. But you need it continuous and uniform. Another is durability, especially when I think about horizontal applications under slab. You want the membrane to be durable through construction. If the membrane is placed horizontally, then a lot of traffic, a lot of people are walking on it. Maybe there's no protection course, and they are placing rebar chairs onto it. So you want to make sure that that membrane is durable, or maybe it does need a protection slab. Not to say that's not durable, but just to protect it from getting possible punctures from other construction practices. Structural integrity, you want to make sure that the right product, meaning, a sample would be, should we be using a liquid membrane, or should we be using a peel and stick in this application? So you basically want to make sure that whatever membrane you're using, it will maintain structural integrity. Resilient, you want the membranes, well, depending on the application, to be tough. And in some instances, you want elasticity, or you want the membrane to be able to bounce back after basically expanding. Factors influencing this effectiveness is you want to have a good design. And with that good design, you want to be able to specify the correct materials for your good design. Then you want to ensure that the right people are installing that material to make sure that it's being installed as per manufacturer's recommendations for that design. And then again, quality assurance. I cannot say more, that, properly trained installers, have your manufacturer rep come on site, third-party consultant also looking, the GC, the architect, the engineer. Welcome all of them on site to make sure it's being installed as per manufacturer's recommendations. Below grade systems, like we were saying before, there is damp proofing. We're going to talk about why it's different from waterproofing, vapor proofing, and a drainage plane. So waterproofing systems, there's not one waterproofing system for every situation. That's why manufacturers have so many different types, liquids, sheets, cementitious, blindside, because there's many different applications, and not one membrane can do it all. And it's very important to differentiate between damp proofing, waterproofing, and vapor proofing. So this picture shows a beautiful example of a waterproofing membrane. Nice and continuous, uniform, properly overlapped. They've sealed the top, they've sealed the membrane to the concrete so that if it does rain, the water's not able to get in between the concrete and the membrane, and that would basically be a failure and need to be repaired prior to putting a protection board and then backfilling. So waterproofing, membranes can withstand the height, weight, and density of water pressing up against them. They will not let hydrostatic pressure into the structure. Also very important with waterproofing membranes, they can span hairline cracks. And to me, this is very important. With construction now, everything is rush. So just say this is a traditional waterproofing application. And a lot of times, especially if this is a summer story, not a winter story, they pour the concrete wall, they pull the forms. Of course, they do the patching of the honeycombs, bug holes, and voids. And then they want them to waterproof right away. So a lot of times, depending on the membrane, 72 hours later, you're able to put on a membrane liquids. A lot of times you can put it right onto green concrete. So definitely, if you're putting it onto green concrete, hairline cracks have not developed yet. Typically, it takes 6 weeks for hairline cracks to show. And what we were talking about before is that if you have cracks, you should be addressing these cracks before putting on a continuous uniform membrane. So how are they going to detail these cracks when they're not there yet? So if you're using a waterproofing membrane, this will address it, because even if hairline cracks develop after the waterproofing membrane is on, waterproofing membranes can expand hairline cracks. So you are safe and you're covered. So waterproofing membranes, that's a very important part, that it can expand hairline cracks. Now you put a protection board on it, and it's very important to put a protection board onto below grade applications, because if without a protection board, now you backfill against it, and of course they're pushing up the backfill against the waterproofing membrane. There's aggregate stones in this backfill. If there's no protection board, one of the stones could push up against the waterproofing membrane, puncture the waterproofing membrane, and now you've laid an avenue for water, for the hydrostatic pressure to come into your structure. Damp proofing. Damp proofing could not withstand hydrostatic pressure up against water up against it. It will eventually let the water through, and it cannot span hairline cracks. So damp proofing, in my personal opinion, is perfect for moisture protection. So if your water table is below your slab on grade, and you have maybe a school or something that has a crawl space or something, you just want to put a moisture protection on there. Damp proofing, again, protection course or drainage plane if you do have leapers around it, but if your water table. And sorry, I see notes going through. Protection board and backfilling. Vapor proofing. Vapor, like I was saying before, this is a good picture that shows horizontal application, and this is a vapor barrier retarder. And as you can see, they're walking on it. There is no protection course on the vapor barrier. So you need your vapor barrier that basically is going to stop or hinder the vapor pressure from the soil into your structure. But it has to be durable through construction on this horizontal application. They're pouring concrete right on top of it. They're putting rebar chairs and rebar. So you want it durable through construction. Positive side waterproofing. So positive side, if you talk to any manufacturer rep out there, they always recommend to place the waterproofing and vaporproofing membrane on the positive side of the wall if it's possible. So, and why that's important, or why we recommend that, is because you are stopping the water and the vapor completely from entering into your structure. So you're putting the vapor barrier and the waterproofing and vaporproofing barrier on what we call the wet side of the wall, or where the water is coming from. So you're stopping it from entering into your structure completely. And there's many products that can do this. There is a sheet waterproofing membranes, and sheet can be peel and sticks, but also what we call Blindside. And Blindside applications are also considered positive applications. And lots of people don't think that, but they are, because you have a soil retention system. Now we're waterproofing, and then we pour the foundation wall. So again, we're stopping the water and vapor from entering into the structure completely. Then we get into fluid applied membranes for positive side. We have cementitious, and what we mean by cementitious is crystalline. And then we have flexible cementitious coatings, and they are fantastic. Basically, they're cementitious with a polymer, and the polymer is what makes them flexible. And then we combine them together in a slurry, and we brush it on. And when it cures, it looks exactly like concrete, but it's flexible, meaning with the polymer, it can span large cracks. And to me, as you can tell, this is very important. And then with any positive side waterproofing, you need either a protection board, an asphaltic, a plastic, it could be insulation, something to stop the aggregate from puncturing the waterproofing, or my favorite is a drainage plane. So a drainage plane can also work as a protection course. It's a protection course and directing the water. So you get 2 in 1, basically. Then we get into negative side waterproofing. Like I was saying before, in some urban applications, you know, when you have structures very, very close together, then sometimes if you have an active leak coming into your basement and that poor owner just wants to stop the leak and regain the use of his base or their basement, you know, how do we address that? If we can't get to the positive side, meaning there's a structure right beside another one and we cannot excavate around to get to the positive side, then we have to waterproof on the negative side. And negative side can be very tricky because you're waterproofing on the dry side of the wall. And a lot of these products that need to go on the negative side to stop active water from coming in needs to have the concrete to be surface saturated. So, you know, so now you have a dry side, no natural water pressure coming. Now you have to surface saturate it to get the waterproofing to work. And I'm going ahead of myself, but negative side waterproofing, why it's not, it's only recommended if you have to, is because you're still letting the water and the vapor into your foundation wall. You have a high possibility of deteriorating your concrete within the wall. And also, you might get possible corrosion of your reinforcing steel. But like I said, in some situations, you know, they have to waterproof on the negative side. Materials that we recommend on the negative side are basically cementitious. Cementitious can stop water, but does not stop vapor. And again, this is really important when we talk about vapor. Vapor, if it gets stuck under a membrane, basically you can have a failure debonding because it's trying to get out. So you want to have a membrane that's permeable, basically breathes. So it stops water, but not vapor. So crystalline can stop water, but not vapor. Also, that flexible cementitious waterproofing coatings will stop water, but not vapor. So they can be used on the negative side or positive side of an application. So material selection, I have no idea why cost is important, just joking. But also puncture resistance is very important, of course. A lot of times you want flexibility in your material. To me, what is very important is ease of application. So when I look at a particular application, you know, do they use a liquid over a peel and stick, depending on the application, depending on the size of the project, and depending on the installer. Some installers don't like liquid or peel and stick. So, but you want ease of application. The easier it is to install, the more success for everyone. Also, installation costs. You want to be able to keep the installation costs because you definitely want another job. Credibility of the manufacturer, of course, is very important, and warranty. Types of materials. We have sheets, fluids, cementitious, and then we have blindside applications. So self-adhering membranes, or what I call peel and stick, are excellent membranes. They're great for vertical applications, horizontal applications. They come in a factory thickness, guaranteed factory thickness. They have a polyethylene carrying sheet and they come in rolls, and the polyethylene carrying sheet stops the rubberized asphalt from sticking to one another. Also, there's a backing paper as well. But because this membrane can go on to horizontal applications and vertical applications, it's a very versatile, good membrane. Torch-on membranes are similar to the peel and stick, and they include fully adhered cohesion systems, factory controlled thickness, just like the peel and stick, flexible and excellent elongation, good resistance to chemicals, and excellent joint detailing. But there's always a but. You know, it's very dependent on the applicator. In my opinion, that is for all waterproofing systems. You need a good applicator, good training, so that they know how to install that particular manufacturer's recommendation. But for torch-on, there's a safety concern, of course. You see this flame and an open flame, so they have to be careful. It's a safety concern. Hot applied systems. They are rubberized asphalts. They adhere virtually to any structural surface, and they have excellent elongation properties. And again, just like torch-on, you know, there's a safety concern, but it is an excellent application. They use this on vertical, they literally throw it at it, and horizontal, and it's still being widely used today. Cold applied systems, they come in one component or two component, and two component, literally they have a catalyst and they mix it together, and a lot of times you have a very limited amount of time to use it, but a lot of times two component, they're excellent waterproofing products, but it just, the time limitation can be a limitation on using the product, basically. Polymer modified, meaning that they're very flexible, have excellent elongation. Again, they span hairline cracks really, really well. They come in water base, excellent for the summertime, or they come in solvent base as well for winter applications. And there is multiple applications. Depending on the manufacturer, though, you have to be careful. Some liquids can only go vertical, some can only go horizontal, and some can go horizontal and vertical. But the major plus of a cold applied is that it can go onto green concrete, but that is a summer application. You would not be able to put a lot of waterproofing membranes, water-based ones in the winter. You have to use solvent. Blindside waterproofing systems. There's sheet blindside waterproofing. There's bentonite, and there's spray applied. And sorry, I'm going to just go back. So what I was talking about before, blindside waterproofing is basically when you have a zero lot line. So if you're down again in an urban area like Toronto, and it's very expensive, of course, property costs now. So the owner wants to use every square inch of their property. So we call it zero lot line. So literally, if you have a soil retention system, again, wood lagging, caisson walls, shotcrete, and anything on the other side of that hole, that owner does not own. So you're putting a big, huge hole, then you're putting a protection course or a drainage plane. Remember, drainage plane can be used as a protection board and a drainage board. Then your waterproofing membrane, which is a blind side, and then they pour their foundation wall. Blind side is completely opposite the way you install it compared to traditional waterproofing or open cut. So again, it's good to have training. It's good to be on site to make sure it's being installed as per manufacturer's recommendations. We have bentonite sheets, and typically bentonite can be placed on a vertical application, a horizontal under slab application, so you can bathtub with bentonite. And something very special about bentonite is that it also can be used in traditional or open cut applications as well. So it's very, very versatile. And the way that it works is that when concrete is placed up against bentonite, it swells 14 times its factory size. And when water, the hydrostatic pressure is pressing up against bentonite, when it swells, that's how it stops the water from entering into the structure. A limitation to bentonite, in my opinion, is the heaviness. The rolls weigh a lot. So ease of application is that is one with the heavy rolls can be a limitation on that. Sprayed applied membranes. Basically, these are sprayed applied blindside membranes need, again, a drainage or some sort of plane that they are spraying onto. And there's a chemical bond to concrete once poured, and they're very dependent on the details over the soil retention system. Sheet membranes. So sheet membranes for blindside application, there's many of them. And again, there's different types that could go vertical for horizontal, or some manufacturers have the same membrane that can be used vertical and horizontal. Sheet membranes, to me, are excellent because on a horizontal application, once they are put together, then they're bonded together. If it rains or snows on the membrane and puddles start to form, you know that the sheets are well bonded together and you're actually getting a bathtub application. All they would have to do is vacuum it up and clean the membrane prior to the pour. So sheet membranes, they're relative, depending on the manufacturer, relatively light. Ease of application is high, in my opinion, and the detailing is quite easy as well. Membrane protection, I've gone over this quite thoroughly, but with, again, there's different types of protection, and protection is very, very important. So for protection boards, you could have asphaltic, you could have plastic, it could be insulation. It could be a vapor barrier, polyolefin membrane. So basically anything to protect the waterproofing from, in a horizontal or a vertical application, from the earth, if you're putting concrete on top of it, if you're putting stones, flat stones, so just protecting it. And another form is a drainage plane. A drainage plane would drain water to its appropriate area, but also protect the waterproofing membrane from anything being put on top of it. This is a great illustration on industrial and commercial drainage planes. On one side, there is a filter fabric, and filter fabric to me is very important because when I keep on talking about the backfill being placed or pushed up against the drainage plane and the protection course, it's letting the water through, but water carries a lot of dirt and soil. So the water's coming through, soil and dirt's trying to come through. That filter fabric is there to stop the drainage plane from being blocked with dirt and soil and so forth. For when we're talking about liquid, blindside liquids, open cut liquids, a lot of times a poly sheet needs to be placed on the dimple side so that when you press the dimple board or drainage plane up against the liquids are not able to fill all the dimples. When we're choosing a drainage plane, definitely on, vertical is very important as well, but horizontal, we have the flow rate, depending on the flow rate, how much water and how much water needs to flow. The strength on a horizontal is very important as well. There's definitely different drainage planes for compression strength for horizontal versus vertical and soil retention. Cementitious waterproofing, before I was talking about crystalline and flexible. Crystalline, one of the things is that you need to have, it's all about water, the way that it penetrates into the concrete. It has to have a surface saturated, at least 24 hours saturated with water, so that when you're placing the slurry onto the concrete, the water is able to bring the crystalline into the concrete and waterproof it. Also, you need to wet cure it for 3 days afterwards, again, to get the water, the crystal into the concrete. This is just showing that with any cementitious waterproofing coatings, there's definitely surface prep that has to be done, meaning filling voids. Also, the brushing is very important because with any spraying or rolling of a cementitious product, you roll in a lot of air within the layers and create pinholes, possible pinholes. But by brushing each layer, you are eliminating the air within that layer and eliminating the pinholes. So then you have a successful cementitious waterproofing coating. With a crystalline, it does not water expansion joints, large cracks, which is very important. And that's the picture of my nails, just joking. But with flexible cementitious waterproofing coatings, basically they span 1.6 millimeter cracks. Again, it's cementitious with a polymer. We mix it together. Again, surface saturated is very important. Having factory trained installers knowing what they're doing to get a successful membrane. So in summary, there is a number of different types of systems available, not one system for every project. You have to look at your application, talk to your manufacturer rep, and decide on what waterproofing is needed for your application. I want to thank you very much for attending my effective waterproofing AIA presentation. I hope it was informative. I tried to be entertaining. But before you go, we have some wonderful one-page master format product organizers. These show all the waterproofing products that we do have through the building envelope and some of our sealers there as well. It really helps on where to place or where to find these membranes for the master format. Please get in touch with your local rep. Also, depending on your application, we try to help on what products should be specified for your certain application. So thank you very much.
Awesome. Great job, Stacy. Thank you very much. I appreciate a great presentation. And we've got a few minutes left for some questions, and there was quite a lot of questions that actually came in. So we'll get to a few of them right now. As I mentioned at the beginning, we will answer them after the fact if we don't get to them today. So I'm just gonna start off with, Stacy, can you say, when you're looking at structures below the water table and the owner doesn't want to be constantly pumping, what are the key considerations that need to be looked at?
The owner doesn't want to be constantly pumping?
Right. I'm going to assume they're probably going to be pumping during construction and then shutting the pumps down after everything is said and done.
Right. So if there's a high water table, you definitely they need to install a dewatering system. So like Russ was saying, this dewatering system during construction basically provides you a dry area so that your tiebacks and your soil retention system is not leaking. Because they drill in ports and then they pump the water out. And in those typical applications, we would be installing a blindside waterproofing membrane. And again, blindside would be going horizontal and vertical. There's no weepers, no pumping system. So you're relying on that waterproofing membrane to stop the water from coming in to your structure. I hope that answers your question.
Perfect. Thanks, Stace. A couple of other questions kind of along the same lines as regards to using both a positive side waterproofing and also a negative side waterproofing. Can you speak to that? Is that a benefit? Is it needed at all? What are your thoughts on that?
My thoughts are, like I say, if you can get to the positive side of your wall, that is I'll just tell you, I do this for a living. In my home, I bought a home and the basement was leaking. So, and I had beautiful landscaping around my home. So yes, it would have been cheaper for me not to excavate around the structure and, waterproof on the negative side, but I plan on staying in this home a long time and I don't want the water to be able to enter into my foundation wall and slowly deteriorate my concrete and reinforcing steel. So I chose to basically excavate around my home, destroy all my beautiful landscaping, and waterproof on the positive side, and replace the weeper, and put a proper granular material down, and make sure that, you know, everything was good before we put, I mean, I changed the landscaping. Now I have a lot of decks, but that's my personal opinion.
All right, sounds good. Thanks, Dace. What types of blindside waterproofing membranes can be used with Shotcrete?
Well, there's many. Bentonite can, a lot of sheets, but, you know, you need to get in touch. Depending on what membrane you're interested in, please get in touch with that manufacturer and make sure, because there's, with us, there's all three of ours, you can. But with certain manufacturers, it's not that you can't, but it's a certain membrane that they want you to use that you would have to specify. So get in touch with your local manufacturer rep and just confirm that you can. Excellent.
So one that was answered through the chat, but I thought it was still a good one to answer for the whole group. Can you say some more about blindside waterproofing and how to tie into existing footings and slabs, which may have different or no waterproofing? And the gentleman has said, I'm thinking of an area like an elevator pit.
Okay, so you want to waterproof the elevator pit? I don't, so what do you mean?
Yeah,
sorry, Russ, I don't understand the question.
I'm kind of reading it as being potentially blindside or pre-applied waterproofing, and then tying in with existing waterproofing on a foundation wall. Is there a method on how to do that?
Well,
I'm kind of looking as like a sheet good or a fluid applied material, tying into it. I know from our standpoint, we have a number of different details for that situation. And I think in the answer that was given, it's every project's unique in that aspect. So it's probably best to reach out to the manufacturer's representative to discuss that and come up with the best solution.
Yes, I definitely agree.
Okay.
With my personal opinion with blindside, it is very important to get in touch with your manufacturer, because, you know, you want to talk about your application, and sometimes you go from a blindside to a traditional, you know, you might have a structure that you have one wall is blindside, and you have three that are open cut. So depending on the manufacturer, how do you detail from a blindside to an open cut application? And the transitions are very, very important. But I mean, we have details, but it's very important to talk to that particular manufacturer.
Right, exactly. There's quite a few proprietary questions, excuse me, that came up that we'll answer after the fact. We don't want to, talk about that for the group. One last question. What about reinforcing penetrations through the waterproofing between the footing and foundation wall?
Oh, yes. Well, again, there's many details. And when you're talking about penetrations, when you're talking about cracks, blindside versus traditional, if you look at any detailing, it's all about doubling up. So we want to detailing around a penetration, if it's horizontal or vertical, or you need a manufactured rep or yourself to go on site, because maybe if it was a blindside application, the raker, is it going to be into the pour? How are we going to make it continuous and uniform? How, there's so many applications, especially with blindside, I guess with traditional as well, but there's many details out there and they should be followed. And if there's something unique, then the manufacturer should definitely be on site with the waterproofer, with the consulting engineer and yourselves, and come up with a good detail to stop water from coming in. I hope that answers your question.
All right, sounds good, Stace. And just one last one, and then I'll cut it off because we've just gone over time a little bit. But everyone, please be assured we will. Well, I got to ask this one first, off topic. But are you related to the singer Joni Mitchell?
Who says?
So, but I mean,
No, she's not my mother. No, you better not. Yeah,
yeah.
I
In all
can't
seriousness,
sing. Trust me.
yeah. In all seriousness, no. When there's insulation under a slab, where would you suggest the under slab waterproofing go?
Well, it has to be, so it'd be granular capillary break, then it'd be your insulation, then it would be your waterproofing, especially if it's a blind side, because you want the blind side, and then they would pour the concrete right onto the waterproofing membrane. Because a lot of membranes, you want the under the slab to bond to the waterproofing membrane.
Excellent. Great. Thanks, Stacy. With that, on that note, I would just like to say again, thank you, Stacy, for a great informative presentation. As always, you are certainly one of our go-to individuals in Canada for this area of our product line. For everyone on the presentation, thank you so much for your time. We hope that you found it both informative and beneficial for everything that you do get involved with. Please, if you would like a copy of the presentation, please send your information to info@wrmeadows.com, as I said at the beginning, and we will get that out to you. And certificates will be sent out, and also to you, and also on behalf of you if you actually had entered your AIA number during registration. So again, thank you all on behalf of WR Meadows. I hope you have a good rest of the day, rest of the week, and everyone is safe and healthy. Thank you.
Thank you.